Picture one AI company considering 3 locations for a single data center. At each site, it asks a utility, how quickly can you deliver an enormous block of electricity? Only one campus may ever be built, but while the company compares land, fiber, permits, price, and power, all 3 requests can enter separate planning pipelines. On paper, one possible data center starts to look like 3. Site shopping is not automatically wrongdoing, but if planners cannot separate an early inquiry from a committed project, they may prepare for demand that never arrives. Connecting a large AI campus is nothing like adding a home or shop. A facility consuming tens or hundreds of megawatts can require a substation, transmission upgrades, extra generation, and years of engineering. Utilities place expected projects into load forecasts. Regional grid operators use those forecasts to decide what the system may need. The trouble begins when one prospective campus appears in multiple territories or remains in a forecast after its schedule slips, its size shrinks, or its site is abandoned. The result is sometimes called phantom load, electricity demand visible in planning documents, but not yet supported by a facility certain to operate. FERC says current rules can encourage developers to shop prospective projects among utilities, looking for the fastest and cheapest connection. Each utility may be studying a legitimate request. Across the wider system, however, those requests can be double counted. That produces 2 futures. In one, nearly every proposal is built, and electricity demand rises at extraordinary speed. In the other, developers select only their strongest sites and leave many applications behind. The grid cannot wait to learn which future is real. Power plants, transformers, substations, and transmission lines take years to build. Decisions made now can commit customers to costs long before a data center turns on. Underestimate real demand and projects face longer delays, while the grid risks running short of capacity. Overestimate it, and engineers can spend months studying facilities that never proceed. Capacity may be reserved unnecessarily. Infrastructure may be built too early, too large, or in the wrong place. California's Public Advocate's Office warns that inflated forecasts can leave ratepayers paying for upgrades that become underused or unnecessary. Those costs do not vanish when a proposed campus disappears. So the question is not whether AI electricity demand is real. Much of it is. The question is, how much of today's requested demand is credible enough to guide billions of dollars in grid investment? In June 2026, FERC ordered the 6 regional grid operators under its jurisdiction to justify or reform their rules for connecting data centers and other enormous loads. One answer is escalating readiness requirements. An early inquiry can receive an early study, but as a project moves deeper into the process, the developer may need to show stronger commitments, such as control of the site, financial security, or agreements protecting other customers if the facility never arrives. FERC also called for cost recovery agreements, so residential customers are not left paying for infrastructure built for a large load that fails to appear. The objective is not to block data centers. It is to move credible projects forward while removing duplicate or uncommitted demand from the planning picture. That balance is difficult. Make the rules too weak, and the grid plans around ghosts. make them too strict, and genuine projects may lose precious time. The best forecast is neither the largest nor the smallest. It is the one that separates interest from commitment and updates as projects secure land, financing, contracts, and construction. But even a perfect forecast cannot make a substation or transmission line appear overnight. When a real AI campus is ready before the grid, some developers choose another path, bringing generation beside the servers. That is where speculative demand ends and the private power question begins. Tap the related video to see why AI's data center boom is creating private power plants.